So in the introduction, y'all, we looked at an animation of collecting a gas by water displacement. So let's fill in our notes, uh, and then we're going to look at some examples. So this is just an application of Dalton's laws of partial pressures. And so we said that gases can be collected over water by using this process known as water displacement. So a gas that's collected over water, we said, is not pure. It's not the pure gas because it also contains water vapor. So if you look at Dalton's law, Dalton said that the total pressure in a container is equal to the sum of the partial pressures. So if you apply that law to this example, the pressure of the gas you collected plus the pressure of water, the vapor pressure of water, when you add those together, that will actually equal to the total pressure. So if we manipulate this equation and solve for P gas, or the partial pressure of the gas you collected, then the formula becomes partial pressure of the gas is equal to the total pressure minus the vapor pressure of water. So let's talk a little bit about how each of these are related to one another and how you would identify each of these components so that you could solve. P gas is the partial pressure of the gas that you've collected using water displacement. So once you get your P gas, the partial pressure of your gas, you could then substitute that value into either the ideal gas law for the pressure or into one of the pressures for the combined gas laws. You just sort of have to analyze your givens and decide which gas law would be appropriate. Now, P total, that's going to either be called P total, obviously, or it could be called the barometric pressure or the atmospheric pressure. So we're going to look at some examples so that we can talk about how would you identify the total pressure. The pressure of the water, this is your vapor pressure of water, and it can be found using your vapor pressure chart, which is on the handout you received in class. And the vapor pressure of water will vary with the temperature, so it's very important that you pay close attention to the temperature at which the gas was collected. So just to remind you, here's the setup that we looked at, and we're going to take a look at some problems where we would use the rearranged formula where we manipulated it to solve for P gas, and then we'll move on to a little more advanced problems where you would use that